Today we will convert this shape into a path that can be followed by a CNC machine. So first, in our CNC simulator, we initialize our workplace parameters. So our coordinate is centered at the workpiece, so our null point at x and y is 0. And to account for the height of the tool bit, we set our z to 150. Now for the speed and feed, our workpiece material is steel. We follow the cutter diameter here and set it there. And then we will utilize these values, spindle feed and feed rate, later on. This is the program that we used. So first, we set the metric units to millimeters. And then we are gonna be working with X and Y plane. The spindle must go first to the machine 0 as specified earlier here. And then we are going to be using the absolute coordinate system. Next, let's change our tool to tool 1 because we have specified tool number 1 earlier. And then let's turn on the spindle. It is now turning on clockwise at 1273 RPM based on our earlier calculations. We rapid traverse to this point here, point 8. We take note of its coordinates and pass it to the G0. We let the spindle almost touch the workpiece material. And then at this point, the spindle goes downward and that it starts cutting the material. And this is why the dot is now orange. And then it moves to P9 using counterclockwise circular interpolation, and then to P2 with linear interpolation, to P3 with counterclockwise interpolation, P4 clockwise, P5 counterclockwise, P6 clockwise, P7 counterclockwise, and P8 counterclockwise. Since our location is where we started, the program has finished. The spindle can now go back to machine 0, and the spindle stops and the program ends with M30. Let's see its simulation. As you can see, our CNC program is successful, and we've successfully turned this shape into the spindle span. These are my analysis on the figure. This is the actual figure, and this is the handwritten program.